Okay, so I'm going to do my best to make a video of all the review problems so that if you want to do really well in the final, you can. You can take notes on all of these problems and then you can use these notes on the final exam. So it has 30 questions. I'm going to do my best to go through here. Okay? Let us begin. Alright, question 1. We're going to solve for r, so we're just going to add 3. And by the way, fast forward, whatever, if you already know how to do certain ones, that will save some time for you. So these cancel out, of course, so then this would be 24, and then divide by 4, so r equals 6. That's what we would type in the blank. Okay, question number 2, that should have a little bar underneath it, just right here. So now if we want to get the m by itself, what we would do is we would actually get rid of the 3, so we got to subtract 3. Those cancel out, so that would leave us with negative m over 9. And we have 10 minus 3, which is 7. And then we want to get rid of the 9 on the bottom and the negative sign, really. So we're going to multiply by negative 9. So on both sides, multiply by negative 9. So the 9's cancel out, and then the two negatives, a negative times a negative is a positive, so that's just m. And then this would be negative 63. Skipped over 3 somehow. Okay, so 3 is dimensional analysis, so we have 11 kilograms, and they tell us the conversion, so if you just put it over 1, they tell us that 1 kilogram is the same thing as 2.2 pounds, so we want the kilograms to cancel out, so we put those on the bottom, so 1 kilogram is the same thing as 2.2 pounds, and then you just multiply straight across with these fractions. The kilograms cancels, and so it will be whatever 11 times 2.2 is, which is I get 24.2 pounds. Okay. Number 4, keep skipping over these problems. So we're just looking for the correct expression. So if the cucumbers are 69 cents each, and you have C of them, which is like some unknown number of cucumbers, and some unknown number of apples, which is A apples, then that expression, 0.59C plus 0.69A, would represent the total cost of that many cucumbers and that many apples. So that's what you choose for the expression. Number 5, we just have to write an equation for this. So what you have to remember is that a sum is plus, so the sum of a number 14, the sum of 14 and a number, I should say, so 14 plus the number x is equal to 18. So that should be pretty simple. Okay, I'm looking for number 6. Alright, so we have these two people, they're collecting stamps, and so we have the first guy, he is this guy here. He has, let's see, this, I'll just write his name. I don't know how to pronounce that. So he has, let's see, he has 60 right now, and then he said they're gonna send him 20 new stamps every single month, or 20 times X or 20 times M, whatever you like to use for your variable. And then this other person, I think is it Cal or Kai, actually, it's Kai. So Kai has 80 stamps, and she probably is getting 16 new stamps per month, so 16x, and then we just set those equal to each other because it says after how many months will they have the same number of stamps. So then we just solve for x, so subtract 16 from each side, 16x minus 16x, and that will give you 60 plus 4x, and then this is 80, and then we want to subtract 60 from each side, so then that would give you 20, and then finally divide by 4, so it would be 5. So it would be 5 months, so that's what we want to put in that spot, 5 months. And if we want to know exactly how many stamps they would have, we just have to plug the 5 into either one of their little expressions. So, for example, it would be 80 plus 16 times 5, because that's what the x is now. So let's see what that is. 16 times 5 is 80, so 80 plus 80, so 160. So 160 stamps, so that's what we would put in this spot. Alright. Number 7. Okay, number 7, we want to solve for n. Now all this means when you solve for a variable is just, get it by itself, and you can see the n right there is being multiplied by the RT, so just divide by that. So if something's being multiplied, you just divide by it to get rid of it. So that would be it. N is all by itself, and it's just PV divided by RT. So that's what we would plug in to the spot there. PV divided by RT. Question number 8. We're trying to figure out how many people can attend the party, and we have an expression here that we're supposed to use, and we know that Allie's parents are willing to spend $310 for the party. So let's see. C is the cost. So it looks like we're going to have 5p plus 200 and then equals, and the cost, it says her parents are willing to spend $310, so we can make a little equation out of that. So then we can solve for p to figure out how many people can attend. So we have 5p, because these will cancel out. 5p equals 110. So it looks like we have how many people? 110 minus, or I'm sorry, 110 divided by 5. So I have 22. Does that look good? Let's see, 110, 5p, yep, looks good to me. 22 people. Okay, so we want to find the graph here that would work. So she alternates between running and walking. So let's see here. So she began by running. So if she began by running, it should be pretty steep in the beginning. So it'll be this one here. This looks like it's pretty steep. And then she slowed down to a walk. So there's the slowing down. And then she stopped. This is stopping because time passes and there's no distance. And then she began running again. So A looks good. Good on that. And let me just make this look a little bit more beautiful. This is so I want to share that PDF as well. Okay. We're looking at number 11 now. So this one we're trying to come up with the domain and the range. It looks like I already have the the answers here, but I kind of want to explain where they're coming from. So when you look at a graph, the domain is all of the x values that are being utilized. In this case, it's all of the t values. So as you look, it starts at 0 and it goes all the way to 165. So, and I have, okay, I see what happened. I have the wrong, this is a different problem. I see what happened. So this particular one looks like it goes from 0 to 165, because you can tell the graph goes right to 165. And then the height looks like it goes from 0, this is the lowest height right here, and it goes all the way up to, in this case, 40,000. So we would put 40,000 right here. Okay? Okay, we're looking at number 12. Okay, the domain values are just the x coordinates, so whatever those x coordinates are. So as I look at this graph, I would say the x coordinates are 4, and then 5, and then 6, and then 7, and 8. And so then you would pick those. The domain is the blank, whatever that is. The range values are the y values. So if you look at this, we have range values. The range, it starts right here. So it's 100. And then the next one looks like it's 150. And then the next one is 200. Has a couple 200s right in a row there. And then 250. And the range is, I'm not sure what they want for that one. This relation, let's see if it's a function. So it is a function. Each domain is paired with exactly one, should be exactly one range member. So you're not allowed to repeat the x's. So 4, 5, so every one of the x's is paired with exactly one range. So you can repeat the y's. If you notice, we have a y twice, we have 200 twice, but you cannot repeat the x's. So I'm just going to make a little note. You cannot repeat x's and still be a function. Okay, we're looking at number, let's see, is this a different one? Nope, same one. So, we're on 13 now. Oh, let's see, skipped over. Okay, there we go. So 13, so very similar to the last one, it just has to do with shoe sizes. So domain are just all of the x values. So it would be 13, and then it looks like 13 is repeated, but then it's 14, and then 15, and then 17, and then 20. And then the domain is it's the age of the males. And then the shoe size, so they're saying that's the y value there. So it looks like we have a range of 5, 7, 9, 10, and we have 11. The range is the shoe size of the males, and the relation is not a function. So a relation is just a set of ordered pairs. So the set of ordered pairs is not a function, and that is because we happen to have we have two people with the same age but different shoe sizes. So the age 13 corresponds to two different shoe sizes. We have a 5 and we have a 7. Okay? Not allowed to repeat those x's. Okay, number 14, we want to pick the graph. So this is a parabola shape whenever it's y equals some x squared like that. So, and then the number that's in front right here, if that number, in this case it's a 1/4, If that number is positive, then it opens up. If it's negative, so if it's positive, it opens up. If it's negative, it opens downward. Okay? So this particular one is positive, so we know it's one of these ones that opens upward. So we can already knock off this one. We can already cross out this one. And now all we have to do is just try to plug in a couple of points so we can figure out exactly which one it is. So if you put a 0 in, that's usually a pretty easy point to plug in. If you put a 0 in for the x, then that whole thing would be squared, so then it would be -2. And that's already enough for us to identify which graph it is. It's this one, because this one hits right here at 0, -2. And you could pick more points than that, but if the one point does the trick, then you're okay. Let's see, do I want to plug in another point? Don't really need to, but I could put a 4 in there. I just want to show you how I'm actually plugging it in. So I have y equals 1/4, and then you're putting the 4 in for the x. So that would be 4 squared, and then -2. 4 squared is 16, and 16 divided by 4, that's what we get there. And 16 divided by 4 is 4. 4 minus 2 equals 2. So that means 4,2 is the other point. And you can see that it hits right there at 4,2. So definitely the one. Okay, we're looking at 15 now. So 15, this says to use the graph, but I honestly think it's easiest just to plug in the x value. So let's plug it in. So we're going to plug in, we're going to have 1/4, we're going to put a 12 in wherever there's an x, so there's a 12 there, and it's like 12 over 1 if you want to think of it that way. And then this would be 12 divided by 4, which is 3, so that's 3 minus 4, which is -1. So what we'd want to put in there is -1. I don't think the graph really helps too much on this one because it's way out here, and I just don't think that's, I just don't think it's very helpful. Okay. Number 16, we want to find the numbers that are part of the sequence. So it's pretty easy. You just plug the numbers in. You start with, you plug in n equals 1, and then n equals 2, and then n equals 3, and then you see what the values are when you plug those numbers in to this function, to this little sequence. So for example, if you want to find f of 1, then it's going to be 2 times 1 squared plus 4, which is 2 plus 4, and that equals 6. So the first number of the sequence is 6. Then you plug in your next number, so f of 2, that means you're plugging a 2 in for the n, so then it would be 2 squared plus 4, so that's 2 squared, which is 4, 2 times 4, so this will give you 8 plus 4, that's 12, so the next number is 12. Then you want to plug in your next number, which is 3. You just go in order, plugging in your positive integers. So f of 3 equals 3 squared plus 4, so this is 3 squared is 9. 9 times 2, that's 18 plus 4, so the next number is 22. So 22. And then the next number we plug in is a 4. So we have f of 4 equals, and I might run out of room, but we'll see here. So we got 2 and then 4 squared, and then plus 4. So that's going to give you 16, this part here, 16 times 2, so that's 32 plus 4, so that's 36. So 36 is your fourth number. Okay, next one is number 17, should be. It's funny how I keep skipping over it somehow. Okay, so we're looking for an arithmetic sequence. What you want to do here is look to see if they keep growing by the same exact amount, by what we call a common difference. So are they growing by the same, the same amount? It's called a common difference because you actually take the number and you subtract the one before it. You can tell 10 minus 9 is 1, so these keep going up by 1. So this one, this one's arithmetic. This next one looks a little bit erratic. It goes up by 10 and then 15 and then 20, so no. This one looks like it goes up by 6 and then it goes down from 3 to -6, so I'm going to say no on that one. This one, let's see, I have to actually subtract these. I don't think that's going to be the same. Those are way too much of a gap. So no on this one, but you would subtract them and make sure. And then these look like it's going down by 2, so as long as it goes up or down by the same amount, then it's arithmetic. Arithmetic means adding and subtracting, so if it's going up by some common amount, adding or subtracting, then it's arithmetic. Alright, the next one, let me make sure I didn't skip one here. Oh, yeah, I did. So 18, we're trying to figure out f of 12. So what I might do is just see what the pattern is. It looks like it's going up 15 every time, so it's going up 15 for every week that you slide over. That's the slope, so up 15 over 1. And so that helps you figure out what your common difference is. So your common difference is 15. And there's a special formula for this, for an arithmetic sequence. It goes like this. It's f of n equals the first term plus the common difference, and then n minus 1. So for this form, it would be f of n equals the very first term. A sub 1 is the first term, which is this term here. So that's 20 plus the common difference. This is how much it goes up or down by. And then n minus 1. So what's nice about this formula is that it will allow you to figure out any particular term way later on in the sequence, like 12 weeks that we're looking for. So we plug in f of 12 and we get 20 plus 15, and that's 12 minus 1. That's supposed to be a minus. And then this would be 20 plus 15. 12 minus 1, of course, is 11. So f of 12, let me do that on my calculator real quick. So 15 times 11 plus 20, I would say 185 on this one. So 185 autographs. F of 12 is 185 as well. So same number for both of those. Okay, that's 18. I should be shooting for 19 here. Okay, 19. We're looking for which of these is in standard form. So standard form is ax plus by equals c. So it just has to look exactly like this. So this one looks really good, right? Because the a is right there and the b would be 1 in that case. This one doesn't look good. It has some extra z, so that's not good. This one does not look good either because it has this extra x squared. That's not good. That's not a linear equation and it's not in standard form. This one's not good for a few reasons. It's got the extra, multiplying by a y, and then it has the y squared, so that's bad. This one looks nice. And this one looks nice. Alright. These powers have to be 1. I think you heard me say that, but this has to be a power of 1. You can't have anything squared and have it be a line. It would be a different graph. Okay, 20, X and Y intercepts. So if you want to find the X-intercept, you always just plug a 0 in for the Y. So you set Y equal to 0 and solve for X. So, let's see. So when I say set Y equal to 0, I mean actually put a 0 in for the Y. So this would be negative 5x minus 2 times 0 equals 20. So what that does, it gets rid of all this here, it makes all this 0. So it's negative 5x equals 20. So x equals negative 4. So the x-intercept is negative 4, and they might have you do an ordered pair, so negative 4 comma 0, that's what it should be. And then the y-intercept, you set the x equal to 0, and you solve for y. So you put a 0 in for the x, so that would be negative 5 times 0 minus 2y equals 20. And then this becomes 0, of course, the negative 5 times 0, so it's negative 2y equals 20. So y equals, and if you divide by negative 2, that would be negative 10. And then when you write your ordered pair, make sure you put 0 for the x, and then it's negative 10 for the y. Okay, I should be looking for number 21. Come on, 21. Ah, there you are. Okay, so slope. So remember, slope is just a calculation. It's just y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So in plain language, it's just subtracting your y's on top over subtracting your x's on the bottom. So the y's on top, that would be 9 minus 17, and then on the x's it would be negative 3 minus a negative 7. So on the top that would be 9 minus 17, which would be negative 8. And then on the bottom, that's actually negative 3 plus 7 because of the double negative. So negative 3 plus 7 is a positive 4, and that reduces to be negative 2. So this particular slope would be negative 2. And the slope is, and I'm not sure, oh, the slope's positive, so we would have a spot. It probably has a drop down for positive, negative, 0, undefined. So undefined would be if you are dividing by 0, that would be undefined. If you had 0 on the top, that would be just 0. Okay, I'm looking for question number 22. Okay, we're supposed to write the equation of the line. So the way I usually do this is I do y minus y sub 1 equals the slope, and then x minus x sub 1. This is called point slope form. So we put the point, so this is the point, this is the little x sub 1, y sub 1, this is the slope. So we do y minus whatever the y coordinate is, so y minus 4 equals the slope, which is negative 5, x minus the x coordinate, which is 7, and then we just distribute. So we distribute, kind of make it look nice. So negative 5x plus 35. Remember to distribute the negative, negative times the negative there. And then we got y minus 4, and then we're going to add the 4 over, so that would be negative 5x, add that 4, so that would make it 39. So that's what we would put in the blank. So this was number 22, so I'm looking at 23. Come on, 23. How I skip over you, I have no idea. Okay, so this one is, we're looking for which one has a greater rate of change, which means it has a bigger, we're looking for equations that have bigger slopes. So this particular slope, you can tell it goes up and over. So it goes up 2 units, and then it goes over 3 units. So the rate of change is 2 over 3. Okay, so slope is rate of change. Slope, I have to say it, rate of change. I'm going to write this down so I have a PDF of it for you. Rate of change equals slope. Okay, so now we just need to look over here, and these equations, remember slope-intercept form, y equals mx plus b, y equals mx plus b. Well, the m is the slope. That's what we're looking for here. So this one has a slope of 1, which is bigger than 2/3. So that's going to be one we need to pick. This one has a slope of 1, so I'd pick that one as well. This one has a slope of 3/4, and 3/4 is bigger than 2/3. 1/2, no. This one has a 1/2 slope, so no. 1/4, no. So that I wouldn't pick that one. Okay. It says select all that apply. Alright, I'm looking at number 24. Alright, so we need to come up with when they will have the same amount, when will they charge the same amount of money. So one of them charges, so let's say jeweler A charges $115 initially, plus $17 an hour. So I'll say X for number of hours. Jeweler B charges $151 plus $13 an hour. So now we just need to solve for X. So I would subtract 13X to get your variables together. So then that would be 151, that would cancel out. This would be 115 plus 4x, and then subtract 115 from each side. I'll grab my calculator out so it'd be a little quicker. 151 minus 115 is 36, and then we're going to divide by 4, so that would be 9. So this would be after 9 hours. They would be the same cost. And we could figure out what the cost is, of course, just by plugging in the 9 in for the x in either expression, and that'll give us how much it would cost. Okay, number 25. Come on, 25. Okay. So we're trying to make money for the student or the high school play, and it says that it costs $200 for the fees, to put it on, the overhead costs and everything. And so we're trying to write a linear inequality that describes the number of student and non-student tickets that need to be sold to actually pay the fees. So it's okay to make more money, it's just not okay to make less money because then we won't be able to pay the fees. So it costs $5 for students, so that's 5 times however many student tickets, plus $7 times however many student tickets has to be greater than, or it could be equal to, the $200. So it's okay that we make exactly the amount to pay off the fees, right? But it also could be good to make more than that. It's just not okay to have less than that. So, good. 26. Okay, 26. Let's see. If the equations in a system of linear have the same slope, there are infinitely many solutions. Sometimes that would be the case, that they would have infinitely many solutions if they have the same slope. They would actually have to be the same line for that to take place. So sometimes they'll have the same slope, but they'll have a different y-intercept, so it doesn't mean that they necessarily have infinitely many solutions. Sometimes they would. If the equations have different slopes, then there is, have different slopes, there is always, if they have different slopes, then that means they're definitely going to cross at some point, always. And then if the equations in a system have the same slope but a different y-intercept, so that means, they go like this, they have the same slope, but they have a different y-intercept, so they're hitting in different places here. Same slope though, they will never have an answer because they never will be able to cross, because they'll be going the same, steepness. Okay, that was 26, so we're getting close. 27. Okay, so it looks like we're selecting the graph and then also the ordered pairs that are solutions. Okay, so this one here, the x is greater than 1, that's a vertical line. So I like to do my own sort of graph off to the side. So this would be a vertical line, and it's dotted because it doesn't have a bar underneath it. And it says it's greater than, so that means it goes this way. Greater than is to the right. And then this one here is in slope-intercept form, so the y-intercept is -1, and then the slope looks like it's -1/2, so you go down 1 and over 2, and it would look like this. And this time it actually has a bar underneath it, so that's solid. And then it says that it's less than, so we would shade below. And what we're looking for is where they overlap. And so when you have blue and red, they overlap and they make purple. So we're looking for that. So those are that's the solution to the system of linear inequalities. So the one that looks like that to me is this one here, because it has the dotted line and it has the correct shading and everything. So then we would pick the ordered pairs that look like they're in that region. So that means we need to obviously know how to plot some points. So 3, -3, it looks like 1, 2, let's see. 3, -3 looks like it's in there. So I'm going to pick that one. 7, -7, let's see, 7, 7, -7 looks like it's in there. 7, -3, 7, -3 doesn't look like it's in there. 7, -3 looks like it's about here. That doesn't look like it's in there. And then -1, 2. So -1, 2 would be like right there, and that's not in the right area either. So I would say just those first two. Okay, 28. We're getting there. Okay, we want to solve by substitution. So let's get the x by itself. So this would be x equals, so it would be 31, and then we would subtract the 7y. So then we would take this 31 minus 7y, and we would plug it in to the x. You know what? Actually, this one looks like it's way better to solve by elimination. I'm going to back up and do this one by elimination. So you can solve them however you like on the final. So this one, I would multiply this top equation by 2, and then that would make this 2x, and then this would be 14y, and then this would be 62. And now I could add these two together, and I could see that the x's would eliminate because they're opposites, and then this would be 9y, and let's do this on the calculator, 62 and then minus 26, so that would be 36, so y equals 4. And then you can go and plug the 4 back into either equation. So I'm going to put it into the top equation because the bottom one has a bunch of negatives. So it's going to be x plus 7, and instead of the y, let's put the 4 there, and then equals 31. So x plus 28 equals 31, so x equals 3. So the ordered pair solution would be 3, 4, and we have to put parentheses for systems like this. Okay, 29. Let's see, where'd 29 go? There's 29. Okay, this one looks pretty nice if you just add them together. So right now, if you add them together, the y's eliminate. So that would be 10x, and then negative 4 plus 1, that would be negative 3. So then if we solve for x, that would be negative 3/10. So unfortunately, this one does come out to be a fraction, so we have to work with fractions on this one. So, or I wonder if we could just make it a decimal. Let's see, because this would be negative 0.3. So maybe I'll do that. So, because you can use your calculator on this. So let's do 3, you know what 3 divided by 10, that's 0.3. So this is negative 0.3. So I'm going to take that and plug it into the first equation. So this is going to be 2 times negative 0.3 plus y equals negative 4. So let's see, 2 times negative 0.3 is negative 0.6 plus y equals negative 4. So y equals, and so negative 4 plus 0.6, that would be negative 3.4. So if we put those two together, we would have negative 0.3 comma negative 3.4. So yeah, I'd probably recommend making them decimals instead of fractions. Alright, last one for the championship. Let's see, 30. Okay, so this one we have to use multiplication, so we have to come up with a plan to eliminate the x's or the y's. So I'm going to try to eliminate the x's, and I'm going to multiply by negative 2 on both sides. The reason why I'm doing negative 2 is because I would like this top term to be negative 6, and the bottom one to be negative 6x, and the bottom to be 6x, and that way we can add them together. So this one's going to be negative, this is going to be negative 6x, and then it's going to be minus 6y, and then that's going to make it negative 12. And now I'll be able to add these two equations together because they will allow me to eliminate the x's because they're opposites. So 15y minus 6y is 9y, and then negative 6 and a negative 12 is negative 18, so y equals negative 2. So then we want to take that and plug it in. So we could plug it into any of those equations. It has to work for all of them. So I would maybe put it into the top equation where there's a y. Okay? So that's going to be 3x plus 3 times y equals 6. So that's 3x minus 6 equals 6. 3x equals 12. So x equals 4. Alright, I think I'm done. So I'm just going to say good luck.